So in this graph, you will notice the fuel consumption and the distance traveled at speeds of 60 kilometers per hour and 90 kilometers per hour. So y-axis is distance traveled, x-axis is fuel consumption. So we need to find the slope, what the slopes mean, and the cost of fuel if we know how much it is, and we want to travel 1,000 kilometers. So that is your y. When your y is 1,000, we need to figure out what the x is and then find out how much money you would have to pay. So first off, notice how I got these slopes or these gradients. So I started at the origin, the point 0, 0, and I chose the last endpoints of both these lines. I don't know the x-axis values. I don't know the y-axis values. I only know the endpoints. So I can only use these endpoints and the origin to find the gradient. So to go from 0, 0 to 3,350, that is a rise of 350 units and a run of 30 units, which is why I have 350 over 30, rise over run. When you divide that, you get 11.7. It's kilometers per liter because your y-axis is kilometers, which was the first thing you did when you divided, and the denominator, the 30, represented the liter, so kilometers per liter. For the green line, same thing. To go from 0, 0 to 32,300, it is a y increase of 300, an x increase of 32, so the rise is 300, the run is 32. When you simplify that, you get 9.375 kilometers per liter. So you should notice right away that the green line, you get less mileage for a liter of gas or a liter of fuel, where with the red line, you cover more kilometers with 1 liter of fuel. So the red line is the better option if you want to save money and you want to travel further on 1 liter of gas. And notice that the red line represented A, which is a speed of 60 kilometers per hour. So it actually saves you money and you cover more distance when you go at a slightly lower speed, according to this problem. So what do these slopes mean? Well, I explained that just above, but basically the slopes mean how many kilometers a vehicle can travel using 1 liter of fuel. So every time I increase 1 unit on the x direction, the y direction increase is represented by these numbers right here. So for every liter, you get 9.375 kilometers. For this one, for every liter, you get 11.7 kilometers. So these are unit rates. Last part, if fuel costs $1.24 per liter, how much more would it cost to travel 1,000 kilometers with both of those? So in order to find this, I actually need to write an equation for each line and then substitute my x and y values into the equation to solve. It's kind of a complicated process, so I'll break it down. To write an equation, I'm going to use the slope and I'm going to use the y-intercept. Notice the y-intercept is 0, 0 for both A and B. So that means your y-intercept is 0. So when you write y equals mx plus c, the c part will just be 0. So there will not be a plus c, there will just be the mx part of the equation. We already found the slope, the m part, for the red line and for the green line. So you'll see that in the equation. In the equation, the red line is y equals 11.7x slope, and the green line y equals 9.375x. Now I need to do some substitution. I am going to travel 1,000 kilometers. Remember, kilometers is the y-axis, so kilometers represents y. So in place of y, I'm going to put 1,000 into both of my equations. Once I do that, I need to solve these equations. So I'm going to divide this equation, both sides I'm going to divide by 11.7 to get rid of the 11.7 and just leave x by itself. For this one, I'll divide both sides by 9.375 to get rid of that value and leave myself with x. Once I do that, I end up with 106.7 for the green line and 85.47 for the red line, which means x is liters. Remember, x is the liters of fuel consumed, and you'll see the difference there. So for 1,000 kilometers, you use more fuel with the green line than you do with the red, which we explained that earlier why that is the case. Last step, if it's 124 per liter, I'm going to take the number of liters and I'm going to multiply it by the price per liter. That will give me 105.98 for the first and 132.31 for the second. So I need to know what is the difference or how much money am I saving driving 60 kilometers per hour versus 90 kilometers per hour. So I'm going to find the difference of those two numbers. I'm going to subtract them and I'll get 26.33. So 26